Hello guys, welcome to my YouTube channel. In this lesson we are going to practice more on how we can remove factors from radicands. Let's take examples. Let's take for example this problem here. We have fifth root of, let's say, 32x to the fifth. Okay, that's one example. So what we can do here is to look at 32, where 32 is actually 2 to the fifth power. Because 32 is 2 times 2 times 2 times 2 times 2, right? So in that case, it means that we can actually write both of them as fifth here. You have 2 to the fifth and x to the fifth. And with algebraic expressions like this one, you can actually rewrite them as, since 2 and x, they have the same exponent, you just write 2x and use parentheses to the fifth power. Okay. So in this case now, what you can do is just look at the exponent and the nth root canceling each other out, something like that, and it becomes what, 2x. This is what you get, okay? This is the result. This, whenever this is odd, you just get 2x. You're not going to have absolute value with that. Let's look at an example so that I can explain the difference with what I'm about to show you. So you have another one. Maybe you're looking for, let's say, 16x to the fourth, and you have maybe fourth here. Okay, it may even be square root, but we're looking at fourth root here. So in this case, what we can do here is to look at 16 as 2 to the fourth, which means you have fourth root of 2 to the fourth, so that's 16 times x to the fourth, which we can write as the fourth root of 2x to the fourth power. And now notice that the nth root here is even. Whenever it's even, your final answer should be 2x with absolute value, okay? That's how you would do it. So please take note. You can see the difference. Here you have 2x, and because the exponent was odd, so, and you're looking for the fifth power, you can say, I mean, not the exponent, the nth root here is odd. Okay, n equals 5, which is odd. So your answer would just be 2x. But whenever you have the nth root is even, n equals 4, which is even, so your answer better be in the absolute value form. Let's take one more example. Suppose you have a, say, to find the sixth root of x to the sixth and y to the sixth. It just means you're looking at the sixth root of x, y, all to the sixth, because both of them have the exponent 6 and 6. They have the same exponent, so you can do that. Finally, they will just like cancel out, because remember that this 6 will divide the exponent. So you get x, y, but because 6 is even, n is 6, and it is even, the final answer will be the absolute value of x, y. Done. But if n is odd, then we won't have an absolute value result, okay? So this is what we're learning here. And we can take one more. This is number 3. Let's take another one, number 4. Let's say we have to find the square root of 16x squared and y to the fourth. So in this case here, you can look for the square root of 16 and all of that. So this is what we can see here. You know that this will be 16 is 4 to the second power. So, and then this y to the fourth is actually y to the second and y to the second repeating. So what we can do here is, and again we know that for square root to have the n equals 2 for square root, okay? This is what we're going to do. We're going to do 4, because 16 is 4 times 4, which is 4 to the second power. And x squared is already there, so I'm just looking for how I can put everything together in one single arrangement. Okay, so you can see what I did now. I know that this is 4 times 4, which is 4 to the second power. It checks, and then you can see x squared, and the other side has that power, because this power here will distribute across. and 2 times 2 is 4, so I have exactly what I need. Now, since I have this result and 2 can cancel everything, so it will be 4x y squared, but with absolute value. So this is how you would solve this problem, because your end truth is even. I hope this is helpful, and come back for more videos.